All right, so just a reminder, you should already have created your notebook, your math notebook for this lesson, the guided notes, and you should have already filled out one of the questions, and anything that's highlighted in yellow, you are going to want to copy down into your math notebook. It's fill in the blank. So the square roots, expressions, product rule, etc. If you need to pause the video while you're doing that, that's perfectly fine. Just resume the video when you are done. And this is the question that you should have already answered based on a prompt that was on a different lesson in your Canvas notebook, Canvas. Okay, square root. If we have something like the square root of 16 and get 4, 4 is considered the principal square root of 16. Principal square root or the positive square root. So if we want to take the square root of 81, we're looking for a number times itself. That will give us 81, and that would be 9. Now this one is the negative square root. So the negatives in front makes a difference. So square root of 9 is 3. Final answer would be -3 with this next one. And remember, guys, any examples you have to copy into your math notebook as well. Just a reminder. We have to do order of operations, which means the square root in this case is what's called a grouping symbol. So we have to do that first. So we're going to add the 36 and the 64 and get 100. And man, that's being obnoxious today. All right, so the square root of 100 is 10. When we simplify the square root of something squared, we're going to end up with the absolute value. Why is that the case? Well, if I took the square root of, let's do 3 squared, I would square it first, so square root of 9, and get 3. But what happens if I take, that's being annoying, the square root of -3? Well, I square it first, so I get the square root of 9, and the square root of 9 is a +3. So in order for this -3 to turn into a +3, we have to take the absolute value of it. Long story short, if you got a square in here, the square and the square root will cancel out as long as you remember to use the absolute value. Product rule, we can either separate them under different radicals as long as it's multiplication, or we can combine them under the same radical. Sometimes it's helpful to do it one way, sometimes it's helpful to do it another way. All right, so let's look at the square root of 75. And we have to simplify it. There's a couple ways we can do this. So the first way we can do this is probably the easiest way, it does take a little bit more time, is to do the prime factorization of 75, meaning do a factor tree. And so you end up with the square root of 3 times 5 times 5. Separate the 5's under their own square root. So you have the square root of 3, square root of 5 times 5, which is 5 squared. We already talked about how the square and the square root cancel each other out. So we would end up with 5 times the square root of 3. The other way of doing this is if you happen to be really good at mental arithmetic, you can notice that 25 is a perfect square and a factor of 75. So you can write it as 25 times 3, and then the square root of 25 is 5. Square root of 3. I am not sure why it's being so obnoxious today, but anyway, it's just randomly throwing out that straight line there. Okay, this one they're under separate square roots, so I am going to put them under the same square root. So I have the square root of 50 times x squared, 50. You can do the prime factorization, or you can notice that 25 is a factor of 50. And this will give me an absolute value of x. This will give me 5. And we have the square root of 2 still left underneath the square root. When we're dividing, again, we can separate it or put it under the same radical. Like this, for example, we can separate this into the square root of 25 over the square root of 16, which would be 5 over 4. That's one way of doing it. This next one, we can put it under the same radical, 150x cubed over 2x. 2 goes into 150, 75 times x cubed divided by x would be x squared if you subtract the exponents. We already talked about the square root of 75 being 5 square root of 3, and x squared, absolute value of x. Okay. We can use a distributive property. We can add radicals as long as if they have the same radicand. A radicand is the number inside of a square root. So if I have something like 4 square root of 3 plus 2 square root of 3, because they have the same radical, we can combine those as 6 square root of 3. Technically, that's using the distributive property. So for this one, top one, we can combine because they have the same radical. So we add the 8 and the 9 and get 17 square root 13. These also have the same radical, so we can combine the 1 and the negative 20 to get negative 19 square root of 17x. Rationalizing the denominator. So let's talk about rationalizing denominator. If the denominator is a single radical, we do a different process than if the radical in the denominator it has 2 terms. So we may have to use conjugates. A conjugate is when this matches this, this matches this, but one is plus and the other is minus. Again, don't forget, anything in yellow has to be filled in. All right, so let's do some examples where we rationalize the denominator. We're going to start with 5 over the square root of 3. Fractions are not completely simplified if they have a radical in the denominator. So what we're going to do is we are going to multiply the denominator by the square root of 3 and the numerator by the square root of 3. What that ends up doing, the square root of 3, off to the side, let's do this. Square root of 3 times the square root of 3 is the square root of 3 squared. The square and the square root cancel each other out, and we are left with 3. This one has 2 terms in the denominator. 2 terms in the denominator, we are not just going to multiply by the square root of 5. What we have to do instead is multiply by 4 plus the square, hold on, let me find my eraser here. Erase. I said 4 plus the square root of 5, and then I wrote 4 times the square root. Let's try this again. This is plus right here, so we need to do minus the square root of 5. There it is, that's what I needed. 4 minus the square root of 5. Now the numerator we just distribute 8 times 4, which gives me 32, and 8 times negative square root of 5. The denominator, on the other hand, we have to multiply. Now, you can use whichever method you prefer to multiply binomials. My students tend to do better using the box method. They mess it up less often, but if you want to use the FOIL method, that's perfectly fine. The FOIL method gives you the exact same answer because it's actually the same thing. It's just a different way to remember that you have to multiply the first 2 terms, 4 times 4. You have to multiply the outer 2 terms, which would be 4 times negative square root of 5. You have to multiply the inner 2 terms, which would be a positive 4 square root of 5. And then the last 2 terms times those 2. Well, this would be negative square root of 5 squared. We already talked about how the square and the square root cancel each other out, so we get negative 5. The 2 inner terms cancel each other out. 4 square root of 5 minus 4 square root of 5, that's 0. And then 16 minus 5 gives us 11. Okay, so n right here is called the index. It has to do with what type of root we're taking. Square root technically has an index, we just never write it. The index is 2, but if we put a 3 here, then we're talking about the cube root. If we put a 4 there, then we're talking about the 4th root, etc. So cube root is what times itself 3 times. The 4th root is what times itself 4 times. You can find that button on a calculator, but it may look like something like that. Don't try to use the square root button if you're trying to do the cube root. I wrote over top of this, but what's inside right here, that's called a radicand. A radicand. And you'll need to know that. I think there's a typo here, to be honest. there should be a little n there and a little n there, and I think it just ended up getting deleted by accident. Basically the exponent and the index cancel each other out. Let's see. Just like with square roots, as long as the index is the same and it's multiply, we can put it under the same radical or separate it. And the same thing with division. We can separate them or put them under the same radical, whatever works best. Cube root of 40. So just like we did the prime factorization of 75 back when we were doing square roots, we're going to do the prime factorization of 40. And this time, instead of looking for pairs of numbers, we're looking for 3 of the same thing. So cube root of 2, 2, 2, 5. This is 3 of the same thing. And the cube root of 2 cubed is 2. And the cube root of 5. We can separate these. Cube root of 125 over the cube root of 27. 5 times 5 times 5 gives me 125. And 3 times 3 times 3 gives me 27. Using rational exponents, you are going to want to get very, very, very familiar with rational exponents. What do I mean when I say rational exponents? It means you can take a radical and write it using an exponent. So if I have the 4th root of x to the 3rd power, I can rewrite that as x to the 3/4 power. This number goes on top of the fraction and the index goes on the bottom of the fraction. Any exponent rules that we've talked about for exponents can be applied with these exponents, even though they are fractions, doesn't matter. Same exponent rules apply. 25 to the 1/2 power, that's equivalent to 25 to the 1st power with an index of 2. That's the square root of 25, which is 5. You can put 25 to the 1/5 power in your calculator, and your calculator does understand that notation. Sometimes that's easier than trying to figure out how to type it in as a radical. Negative 4th root of 81 to the 1st power. 4th root of 81 is 3, so your final answer is -3. This time we have a negative exponent, so we're going to put that in the denominator. And then take the cube root of 27 to the 1st power. Final answer is going to be 1/3. All of this material that's in Chapter P is a refresher of information that you would have learned in prior classes. All right, so we already talked about this. The number on top is the exponent and the number on the bottom is the radical. It can have the exponent on the outside or the exponent on the inside. Okay. What else do we have? 27 to the 4/3 power. You can put that in your calculator, but let's see how to do it by hand. What we're going to do is rewrite this in radical notation. So the number on the bottom is the index, and the number on the top is the power, put the power on the outside, even though you can put it on the inside. If you put it on the inside, you would have to take the power first, which would do 27 to the 4th power, which is a huge number, which you would then have to take the cube root of. It's easier to find the cube root first and then take that to the 4th power. So it's easier to do it with the index first and then the power. What do we got? Properties of exponents. All right, so we're going to multiply the 2 times the 5, x to the 4/3 times x to the 8/3. So 2 times 5 is 10. We're going to add the exponents. So 4/3 plus 8/3. 4/3 plus 8/3 gives me 12/3, which is 4. All right, learning reflection. What did you learn? What part did you find most helpful? Do you need assistance?